Drought and fire, floods and landslides. You see these things happening on opposite sides of the world, and they feel like two opposite, equally devastating extremes of nature.
But what if they aren't random events at all? What if they are, in fact, two sides of the very same coin? Ooh, spooky. Sarah, what was that?
I was just adding a little mystery vibe, Greg. You know, setting the mood.
Right. Well, it sounds like a ghost is ordering a flat white. Please, just don't.
A coin, as it turns out, that's controlled by a single incredibly powerful climate engine right in the heart of the Pacific Ocean. This engine is called the El Niño Southern Oscillation, or ENSO for short, and it is, without a doubt, the most influential natural climate pattern on our planet, dictating the weather for billions of people.
Now, to understand how this engine can break down, we first need to get a handle on its normal state. This is what we call the ENSO neutral phase, and it's all dominated by this massive atmospheric loop. Okay, let's dive into this.
This loop is known as the Walker circulation. It's this huge self-reinforcing system, and the whole thing gets started with the trade winds, which consistently blow from east to west, right across the Pacific. What does that sound? It's my wind kazoo! I just felt the standard whoosh sound effect was a little too aggressive. This one sounds more persistent. It sounds like a balloon is dying, Sarah, a very, very slow and sad death.
So, these winds, please stop, they push the warm surface water all the way across the ocean, piling it up over in the west, near Indonesia. This warm pool then pushes down on something called the thermocline. I'm sorry, I just don't believe that's my character's motivation. What? Dave, you're not even in this part. This is the neutral phase. This is the literal absence of you. I know, Greg, I know, but I'm trying to find El Niño, and he would never call it a thermocline. It's more like the warm blanket of the ocean, man. It's the boundary layer between warm and cold water. That is the scientific term. Can we please just move on? Okay, deep breath. As the warm water moves west, cold, nutrient-rich water from the deep ocean gets pulled up to the surface in the east. This whole process is called upwelling. Fish! Nutrients! Wait a minute, is that a maraca? You brought a maraca for the fish nutrients. It sounds like nutrients. It sounds like a fiesta. Okay. This temperature difference creates a loop. The warm pool makes rain and rising air. That air sinks over the cold, dry east, and the whole cycle powers the very same trade winds that started it. It's a self-reinforcing engine.
But then, every few years, the engine breaks. El Niño arrives. And it's really important to understand this. It's not more heat being added to the system. It's just a massive relocation of the heat that's already there. It's a complete breakdown of the normal state. And it all begins when those persistent trade winds relax. The winds, they just let go. It's all so tiring, you know? Is that your El Niño voice? You sound like you're about to write some sad poetry and then take a long nap. He's not lazy, Greg. He's exhausted. He carries the weight of the world's weather on his shoulders. The pressure, it's just immense. He needs a break. He's a relocation of heat, Dave. He's not an emo poet.
So the key here is that without the winds holding it back, that huge pile of warm water in the west just sloshes eastward, spreading across the Pacific toward South America. And the warm pool, it just sloshes eastward. It has to be free. Right. And this cap of warm water then completely stops that cold, nutrient-rich upwelling near Peru. I stopped the upwelling. It was too much effort. The entire atmospheric chimney of rain and rising air just follows the warm water east. The chimney followed me. It understands my journey. And this one fundamental change causes catastrophic flooding in Peru and, at the exact same time, severe drought and fire risk in Australia and Indonesia. Tragic, but that is the truth of the slow.
Okay, let's move on to the other side of this coin. If El Niño is a breakdown of the normal state, well, its counterpart, La Niña, is something else entirely.
If El Niño is a breakdown, La Niña it's a supercharging.
Hello, Pacific. Ga, Sarah.
La Niña is the girl, and she is here to work. The trade winds get stronger. We push more warm water even farther west. We're organized, we're efficient. And the upwelling of cold water in the east becomes really intense. We're talking colder than normal, more nutrients. Fiesta, fiesta, fiesta. And the rainfall over the far western Pacific becomes much heavier, leading to intense flooding for regions like eastern Australia.
All right, thank you, Sarah. So we've got this massive natural pendulum swinging back and forth every few years. We've got the lazy one, the manic one, and the normal state in between. But what does all this mean for the planet's deadliest storms? You know, hurricanes, typhoons, and cyclones.
So here's how ENSO actually pulls the strings. It's not just about warm ocean water, which is basically the fuel for a storm. The most critical factor it controls is something called vertical wind shear. You can just think of it as a storm kill switch. High wind shear is like a powerful crosswind that literally blows the top off a developing storm, tearing its structure apart and killing it before it can get strong.
And this brings us to a huge misconception. You know, people hear El Niño, they think warm water, and they automatically assume that means more storms everywhere. But the science on this is really clear. The total number of tropical cyclones around the world stays pretty stable year to year. ENSO doesn't create more storms, it just relocates the risk.
And this slide really illustrates the whole point perfectly. ENSO acts like a giant atmospheric seesaw. So during El Niño, the changes in airflow create high wind shear over the Atlantic, which acts like a powerful shield that stops hurricanes from developing. But on the other side of the seesaw, in the Eastern Pacific, the shear is low, basically rolling out a welcome mat for storms to form. And then during La Niña, the seesaw just flips. The Atlantic becomes active and the Eastern Pacific is suppressed. It's an almost perfect inverse relationship.
But here is the crucial twist in our story. This completely natural cycle, this planetary seesaw of risk, is now performing on a totally unnatural stage, one that we ourselves have warmed up.
So let's be crystal clear about this distinction. ENSO is the natural pattern that decides where the storm danger is pointed in any given year. It's all about relocation. But human-induced climate change, that's the unnatural, long-term trend that's just adding more fuel to the fire, supercharging the storms within that pattern. That is amplification.
So while the total number of storms isn't really increasing, the scientific consensus shows that the proportion of high-intensity Category 4 and 5 storms is. Warmer oceans just provide more energy, and that fuels more powerful storms. It means the storms that do form, wherever ENSO happens to point them, are simply more likely to be destructive.
So, after all of that, what's the final takeaway here?
First, ENSO is a natural pendulum. It swings back and forth, and it relocates storm risk around the globe like a seesaw, not a multiplier. And for a place like the Philippines, this has really complex effects. El Niño often brings fewer storms overall, but a higher risk at any storm that does form could become a catastrophic super typhoon. La Niña, on the other hand, acts like a magnet, pulling more landfalling storms directly toward the islands.
The Pacific's weird and restless children are a completely natural part of our world's climate. El Niño, the exhausted poet, and La Niña, the overcaffeinated enthusiast, they're always going to be with us. But the final question we're all left with is this: are we, through our own actions, giving them a more dangerous world to play in?